This illustration helps you to understand the algorithm involved in displaying the 7-segment numbers, or how do we generate the 7-segment codes from the program and drive it to the respective ports as and when we are in need of displaying a digit. In our earlier discussion, we got to know that there are corresponding 7-segment code which are generated in hexadecimal values which need to be sent to the respective ports so that it can display the digits. For example, the digit 0, if it needs to be displayed, we generate a hexadecimal value 3F through the port and send it. Likewise, for 1, we see there was 6 as the hexadecimal value, for 2, 5B, for 3, 4F, for 4, 6, 6, etc. So we have altogether 16 possible occurrences of these 7-segment codes based on the number that we are planning to display. Correspondingly, we need to have these 7-segment numbers being stored, or 7-segment codes being stored in 16 different memory storages, for which we hire an unsigned character array of length 16. So the illustration on screen helps you to understand how this is getting visualized. SSC refers to the unsigned character array name, and 16 is the dimension, and these are the respective locations which are going to hold those respective 16-bit data. The 0th element of this array is expected to store the 7-segment code of 0, which is going to be 3F, and the first array position 01 refers to the data which is going to be stored for number 1, which is correspondingly 06, and for 2 we see that there's 5B, for 3 we have 4F. Likewise, each of these locations are going to be stored with 7-segment codes of numbers from 0 to 9 and characters A to F. Once the array is defined with these 16 7-segment codes in place, thereafter we are supposed to refer to each of these data by referring to the respective array index. For example, SSC of 0, that means the 0th location of the array is identified, and the moment when we refer to SSC of 0, it is pointing at 3F, and when we refer to SSC 5, it refers to the 5th location, and 6D is going to be the data that is going to be picked. Hence, when we see that the 7-segment displays are connected on, say, port 1, when we refer to P1 equals SSC of 5, what ends up is the compiler will refer to 6D, which is the 5th element of the array SSC, and that 6D is being put on P1. So 6D corresponds to the 7-segment code of 5, digit 5, and when this data get transported through P1, it end up displaying 5 on the 7-segment display. Even in this scenario where we have a for loop in which these array references are made with a dynamic reference of the index value with I. That means we are not going with the fixed value reference of the array. I takes different values for each occurrences, and when I is assigned with 1, SSC of I will refer to the first element, and then it will end up sending 3F to P1, and when it is assigned with 2, I is updated with 2, and then the second element, which is 5B, will be sent to P1, and when I is updated to 3, the third element from the array, which is going to be 4F, which will be sent, and once the array is updated to 5, the element 6D will be sent to P1. So thereby we can send the respective array element to the port 1 as and when need arises.